So this is 1-4, part 2, the explicit rules. And first one I'm going to do here on your homework is number 4. In June, you start a holiday savings account with a deposit of $100. And you increase each monthly deposit by $10 until the end of the year. Oh, so until December, presumably like December the 1st. So in July, you put in 110. In August, you put in 120. In September, you put in 130. Where am I at now? October, you put in 140. November, you put in 150. And then in December, you put in 160 bucks. Now, I want you to realize that I'm doing this right now recursively. Like, this is straight up recursive. And it's not hard. Now, how much money did I put in altogether? Let's see, I put in 210, right? 330, 460, 600, 750. I lost my place there. It looks like 910. Let me run over that again. 310, 450, 580, 700, 810. Yeah, $910. So you deposited $910 bucks. Honestly, this is probably the easiest way to do it. It's not that many months you're writing down. So this was a recursive train of thought. Now let's talk about the explicit train of thought. I think time-wise are about the same. You would be writing a rule by saying that the nth month is the first term of 100 plus n minus 1 times the difference, which is 10 bucks, because you keep depositing $10. That's the explicit rule. You clean that up by distributing your 10. You'd have 10n, looks like plus 90. Okay? Is that right? Yeah, 10n plus 90. That's your explicit rule. Now, you could turn around and you could use your summation rules that the sum of n terms is n over 2 times the first term, a sub 1, plus the last term, a sub n. So I kind of have to figure out, which month. Normally we think about December being a 12th month, but based on us starting in June, we can see it's a 7th month. So it would actually be here a sub 7. And I could find the 7th month pretty quick. It'd be 10 times 7 plus 90, which is 160 bucks, just like you did. And I could use Gauss's little formula here. The sum of 7 things is going to be 7 divided by 2 times the first month, which was $100, plus the last month, which is 160. And I just feel like doing this by hand. The sum of 7 things is going to be 7 over 2. I'm going to have a 260 there. Now I'm going to take half because it's 7 over 2. Half of 260 is 130. So I'm going to have 7 times 130. 7 times 100, 700, 7 times 30 is 210. Put them together, $910. I don't know which way is quicker for you. I would probably choose explicit still to this day because, I wrote this out, typed it out. That obviously took longer. I don't know. You decide who you want to be. But as short as this one, recursive for 99% of the population is probably the way to go. Think recursively. But you can do it explicitly as well. Pick your pill. Red pill, blue pill. Nobody cares. Pick one. Go with it. Let's see here. Which of the following sequences are arithmetic? By the way, arithmetic means we add or subtract. Adds or subtracts. A common, that's the deal, it's common difference. So this one right here, I'm not going to write it down, but it's definitely not arithmetic because we add 10, then we add 20. It's something else. 1, 4, 9, 16, so we add 3, we add 5, we add 7. We add 4, we add 4. It looks like only 3 is arithmetic. So I actually just did all that for you. Hope you wrote something down. Translate between. So I'm going to do one of the translations. This one you write a recursive rule. So your goal here, of course it's been a day and you've slept since we talked about recursive rules. Your goal is to write this. A sub 1 if n is 1 a sub n minus 1 plus the common difference if n is bigger than 1. Now this thing is actually laid out in the form a sub 1 plus d times n minus 1. It's actually giving you everything. So a sub n is a negative 2 if you're the first term. That's why we say n is 1. And you are the previous term, a sub n minus 1, plus 7 if n is bigger than 1. That's how hard it is. It ain't rocket science. Now let's go the other way around. Your goal here is to go from recursive to explicit. So this tells me right here that the first term is negative 4, and this tells me that the difference is negative 4. And all you have to do is have to know a form. The explicit form for an arithmetic sequence is a sub 1 plus n minus 1 times d. And some people put the d in front. It doesn't really matter. Pick it, I don't care. First term is negative 4 plus parentheses n minus 1 times a negative 4. Now I like kids to stop at something that looks like y equals mx plus b, because that makes them realize that hopefully that arithmetic sequences are linear in nature. So we're going to distribute the negative 4. That'll give us negative 4n plus 4. We just combine like terms. So in standard form, we would lead with the variable. Negative 4 plus 4 is 0. And that is the explicit rule for the nth term, which is awesome if I wanted something like the 60th term, as opposed to doing it recursively where I have to write out all 60 terms. Please appreciate what explicit does for you. Don't want to do 11. Let's look at these. Alright, so I'll do part 1 of 12. Find the sum of an arithmetic series with a given number of terms, a sub 1 and a sub n. And they want you to find 10 terms, and they gave you the first 2 terms. So this is using Gauss's little formula. The sum of n things is n over 2 times first plus last. In this case, that's a sub 10. Okay, so there are 10 terms. You're finding the sum of 10 things. It is going to be 10 over 2. First term is 4, last term is 31. And then you do some math, right? The sum of 10 things is going to be 5 times 35. 5 times 30 is 150. 5 times 5 is 25. You put them together, you get 175. Easy peasy lemon squeezy. I'm going to do a sig notation down for you. Now you do have to remember something, and it's about the bottom piece, okay? So if it does not start at n equals 1, and this always works, but specifically if it's n is not 1, if it does not start at n equal 1, okay, the number of terms is always high minus low. So the big number is 12, and we take away 3. Oh, plus 1. I almost forgot 2. Plus 1. So 12 minus 3 is 9. You add 1, you get 10. This thing has 10 terms. A lot of kids, they just like to look at the top number and think it has 11 terms. That works on this one. This one has 11 terms. If you had 11 fingers and you started counting at 1, guess how many fingers you'd hold up? You'd hold up 11 fingers. But if you start at 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It took all 10 fingers to count from 3 to 12. So anyways, we have 10. Now, the first term on this one is actually a sub 3. This is where our particular series starts. And to find a sub 3, we plug in a 3. And we get some fractions, row. You know, what's 3 halves minus 9? Well, that's 3 halves minus 18 halves. I'm expecting that you remember 5th grade math. I know that's an issue. And you get negative 15 halves. The last term is a sub 12, so we plug in a 12. That'd be 12 over 2 minus 9. We do get a much prettier number here. 12 over 2 is 6. 6 take away 9 is negative 3. And then we're going to use Gauss's little formula. Remember, you're finding the sum of 10 things, not 12. 10 things, not 12. It's going to be 10 over 2. And inside we're going to have negative 15 halves plus a negative 3. Let's go ahead and put those two things together. 10 over 2, by the way, being 5. Negative 3 would be like, negative 3 halves is negative 6 halves, right? Negative 3 is negative 6 over 2. Negative 15 plus 6 is going to be negative 21. So we got 5 times negative 21 halves. Boy, that orange is hard to see, isn't it? All right, so 5 times 21 is going to be 105. Negative 105 over 2. And there you go. If you like decimals, use a decimal. That could be negative 52.5. Anything else off your homework I care to do? I'll do 15, because if I don't, it's just going to get asked. A race car driver travels 34 feet in the first second of a race. If the driver travels 3.5 additional feet each subsequent second, how many feet did he travel in 52 seconds? So this is your first term, and this is your common difference. So my explicit rule for this race car driver is 34 plus 3.5 times n minus 1. And we're going to make this in standard form. That'd be 3.5n minus 3.5 plus the 34 you already had. 3.5n plus 30.5. That is the nth term. If I want to know how many feet he traveled in 52 seconds, by God, I'm going to feed that thing to 52. Ace of 52 is 3.5 times 52 plus 30.5. What's that going to be? 150, 176, 206.5. I feel like that's 206.5. Now, that is the 52nd. That's the distance traveled. On the 52nd second. Okay? That's not how many total feet he traveled. So we got to do a little math here. I'm actually going to find the sum of 1 through 52, the sum of 52 terms, to figure out the total distance traveled. It's going to be 52 over 2 times the first term, which is 34, plus the last term, which is 206.5. 52 over 2 is going to be 26. 34 and 206.5 is 240.5. I really want to multiply those together. Oh, how crazy am I feeling today? Yeah, why not? We'd have 2405, 2405, 1200, 1440, 1443. So what I did here is I did 10 times 240.5, 10 times 240.5, and then 6 times 240.5. 12. Yeah, I'm good with those numbers. Old school 5th grade math. We got what, a 13, we got a 5, right? We carried the 1, we got a 12, carry the 1. So, 7,253 foot. I'm a little too tired to do that in my head, but I'm pretty confident it's the right answer. So, part 1 is 7,253 foot. Now, feet doesn't mean much. Most of us think miles. But there's 5,280 foot in a mile. So, mile and a third maybe. 1.3, 1.4 miles. All right, part 2. How many seconds will it take to travel 20,725 feet? So what we have here is we have a sum. And the question is how many seconds? So let's write down our summation formula. It's n over 2 times the first term plus the last term. Oh, man. I wish I hadn't undone that, because let me go back in time here. There it is. I'll need to leave that there. The sum of n things is n over 2 times the first term plus the last term. Now, you have no idea what the last term is, but, and hear me out, you have a formula for it.
And you are familiar with the substitution property because to get into my room, you had to pass Algebra 1, right? And 8th grade math, and 7th grade math, and probably geometry. So even though I have no idea how many things there are, and that's the actual question, I do know the first term is 34, and I know the last term is 3.5n plus 30.5. I know those things, okay? And then I can do some math. And I actually know what the sum of those things were. The real question is when Milbrath made this problem a couple of years ago, did Milbrath do it correctly, or is there a mistake that I keep forgetting I should correct? That's the real thing. Alright, so let's clean some stuff up. The opposite of division is multiplication, so we're going to 2 both sides. We'd have a cancellation here. 2 times 20,725 should be 41,450. On the right-hand side, we can put together these two numbers. We have 3.5n plus 64.5. We're going to do a little subtraction here. And at this point in time, I'm going to pull up a calculator because I'm just wasting everybody's time by doing it by hand. There's my TI-84. So what are we doing here? 41,450 minus 64.5. It's going to give me 41385.5 on the left. 41385.5. And it's equal to 3.5n on the right. So we're just going to divide both sides by 3.5, and we're going to hope that Milbrath has not made any mistakes. And evidently I did, because that number is way too big. Way too big. It should not take 11,000 seconds to travel that many feet. So what did I do wrong? 50 seconds said we're traveling 200. Something seems off. Let me pause this while I find my mistakes so I don't waste your time. Well, I can tell you boys and girls that I am a complete idiot. I was paying attention to the clock and rushing myself. And what I didn't catch, just being careless, bad math teacher, is that there was still an n here. So, this is not actually that easy of a problem. We have to distribute that n. That'll give us 3.5n squared plus 64.5n. And how do we solve that thing? Well, we set it equal to 0. I'm missing something. 450 minus 41450. Now it would be really cool if everything up there was divisible by 3.5. I don't feel that it is, but I'm pretty tired. It's not. Do you know how you solve this one? You do something called the quadratic formula. As x equals negative b plus or minus square root b squared minus 4ac all over 2a. That's how you do it algebraically. Or you use decimals. And I'm going to use decimals. If I had more time, I'd probably do the quadratic formula. But I am low on time. So plus 64.5, there's supposed to be an n there. See, there's the bell.
minus 41450. Okay, so I'm using what's called the zero product property, so I want to see where it touches. There she is. 100 seconds. There's also this guy over here, which is extraneous, but this is the answer I'm after. 100 seconds. Remember, a picture is worth 1,000 words. So, n is 100. It means it took 100 terms to add to 20,725. So 100 seconds. Now that's a minute and 40 seconds. And this is a roughly, maybe 3.8 miles. Car's booking it, man. I don't think it's a realistic problem. Sorry for the brain fart. I have them. You're going to notice that. I don't claim to be perfect.